I'm here to actually explain how we solve the challenging web application automation problem using artificial intelligence and machine learning. Uh, so one of the things which we've been trying to solve is trying to make machines think more like human. Because as of now, most of the automation solutions does not have the capability to uh, think or understand the web application it is testing, or to say, it cannot understand what the machines are trying to tell, what the applications are trying to tell back to the machines. So the idea is to build more intelligent automation systems which can actually understand the application it is testing or auditing and be more human-like in approach in the way it is testing. So myself, Rahul Shashi, I'm the co-founder and CTO of a cloud security company called CloudSec. I, along with my co-founder, Mohanlal Menon, has started this company in 2015, and we primarily focus on cloud application security and vulnerabilities related to that. So our main focus is data leakages, and in my talk, I would explain one of the open source modules which we have, which actually solves the problem which I mentioned before. So since you all know the most number of security issues reported to Facebook was insecure direct object references, where the bug was simply replacing a particular user ID with another user ID, and he was able to get access to the second user's data. Here, the exploit is very simple, the bug is very simple, but the problem is identifying these bugs are very, very difficult. Mainly because, and it's very difficult to automate these sort of bugs, the indirect direct object references, it's very difficult to automate them. The main reason is the tools which are the automated tools, right? They do not understand the context of the application which is scanning. They treat, and also, these sort of bugs are very time consuming because you have to go through each endpoints, try to mutate the value to a different ID and try to see the response, and you have to do it with like 100,000 requests, and then only you would be able to find a bug. So finding these bugs are very time consuming and it takes a lot of time. So the main problem why it's not automatable is because current application scanners are very blind. They are not intelligent enough. They do not understand the application they are scanning. They treat every web pages as an HTML form and nothing more. So the scanners does not understand the human language at all. And these days, most of the modern web applications are built on JavaScript. So you have to actually trigger the JavaScript, or you have to trigger an endpoint in order for the request to, in order to trigger the request, then only you would get successful attacks, can launch successful attacks. So for example, you can see this particular form. This particular form is asking the ender to enter a phone number. If it doesn't enter the phone number, it would not trigger the second request, that is phone number update successful. If the scanner enters any other character or integer over there, the validation would fail and you would not trigger the second request. So this is a very common problem with almost all application security scanners. That means they do not understand what the application is trying to talk back to them. They do not understand the human language. So like I said in this example, if and only if you enter a phone number, you would actually trigger the second request. Else the second request would never be triggered, and you would never be able to identify any security issues which would happen in the second request. Same goes for another problem. That means the dialog boxes where the user is asked to interact, where the user is asked to choose a particular option out of the two, and if only he choose the right option, he would be able to trigger the right API, delete data API request. So if you press cancel, the request would never be triggered. If you press OK, then only the request would be triggered. So these sort of interfaces are very common in the new JavaScript based web applications, and and my talk would explain how we could solve this particular problem and how we could make more intelligent automation solutions using AI. So, quick disclaimer, we are not trying to rewrite the entire application security automation methods. We are just trying to improve them. We are simply trying to make the automation more human-like. So in the talk, we would have a little bit about web application automation and how we could make the scanners think more human. For that, we use a little bit of machine learning concepts, a bit of AI concept, artificial intelligence concepts, and that's how we build these intelligent solutions. So we are trying to make the machines think as normal security researchers approaches a web application. And the same concept could be utilized to automate mobile applications and any other automations which you wanted to. So technically, when we started this project, we wanted to solve the following things. We wanted our tool to understand the application it is scanning. We wanted to build more context about the application it is testing. So for example, if the application is scanning Twitter, and if it's scanning an e-commerce site, it should understand that it's dealing with an e-commerce site. If it's testing a social networking site, it should understand that it's dealing with a social networking site, and that there are different patterns for each of them, and how it would identify it should be from the previous learning. So every time it does a testing, we wanted our tool to get better, and it should learn from the past experience so that it would get better over and over again. So basically, simply to build a system which uses it in the same way a human does. So when all of us use a web application, right? So one of the first thing when you start testing an application is you first go to the main page. You try to see if there is a register user option there. If there is a register user option, you first register an account, then only you go into logging into that account. So there is a pattern which you follow when you use a normal application, and that pattern you have created, based on our research and the understanding, we understood that pattern was created based on the learning which you have done in the past many years. So always you first go to the register page, then register an account and bring that account to the login page, and then only you will trigger the forgot password. If you don't follow this pattern, you would not get the right results, and that's what other tools test. They don't follow the pattern, they don't follow the human-like pattern. Feel free to stop me and interrupt me if you have any doubts in the things which I'm saying. So in this demo, I will have live demo as well. What we are trying to understand is you have the Twitter page. The tool actually is built on top of a browser. It actually navigates to the login page first. Then it finds it's trying to trigger the forgot password option. So here it understood that the application is asking for 3 different options: phone number, username, or password. So it enters an email address, and there were 3 different steps in order to trigger all the requests, and it successfully was able to trigger all the 3 different. It was successfully able to interact with all the different options on this. So first it went to the login. Instead of signing up, because it already had a user account, it went to the login page. It identified the login page. It identified, it's now trying to trigger the forgot password option. It entered whatever the application was trying to tell. So it took 3 different requests to trigger complete the successful interaction of the application. So what we do is we use natural language processing, NLP, to automate, so that whatever the application tells back to the scanner, it understands what it is saying, and it provides a required output based on that. So that's pretty much what it is happening over here. So these sort of things, other scanners because it doesn't understand the language, it would not be able to trigger. So I'll go straight into the implementation details, how we have implemented this. So for NLP, for identifying that a particular term is related to something, we started categorizing. So it's a supervised learning algorithm which we have used, where we have created labels. So each label called sign up, create new user, register now, or anything which is similar, we all categorize them into a group called register user. And anything which has got called forgot password, reset password, forgot your password, reset now, etc., etc., we all term them into another label. So we created different labels which was used throughout a web application, and we build the training data. So once we build the training data, so once we build the training data, our objective is, if the web application encounters a label called enter your email, phone number, or username, the application should only enter this particular data. If the application is asking the user to trigger a particular request or continue, it should press that particular button. So interacting with an application the way a human does is exactly what we'll achieve from this. So like I said, once you tokenize this, categorize this, this is the training data which we created. You have to remove the stop words. So what we did is, the stop words which are like your, semicolon, etc., are not important in the conversation or in the context. So we started removing them, and then there is a process called token extraction, which is when you do the filter word and stop word removal, you will be able to do the token extraction. And so we have to actually now convert this text into some sort of representation which a machine understands. So since we're building automating it, we're using NLP and machine learning, we have to convert the text into some form of format which a machine or the code understands. So for that we used a vector space model where text is represented as numbers instead of its original string, and we use this for the supervised model machine learning algorithm which we built. So like I said, the training data, so these are the training data. Like this, we created a huge amount of data sets which were used for the training data, and then we ran this training data over our machine learning models so that it would understand or it will categorize what each label is trying to tell the user. So so there are different ways of vectorization. We choose the TF-IDF vectorization, and there are other ways called bag of words and hashing vectorization. The reason we choose TF-IDF was we found it more better than other options we had. So TF-IDF vectorization is very simple. It's the algorithm is like term frequency divided by the inverse document frequency. So you basically, how is null conference better than any other conferences? So you basically take the total number of terms and then divide by, how frequent that verb is. So the equation is very simple, and you get a vector representation of the string. So once you have that vector representation, you would be able to now classify. For example, when you encounter please register, and you would be able to understand what classifier it belongs to. So the classification was very simple. So I'll just go into the classification algorithm we used. Again, there are multiple classification algorithms. We tried a lot of them, and we chose naive Bayes. So naive Bayes is also very simple. You tag different documents like forgot password, reset password, forgot your password, reset now, etc., etc. And then we tell them that so if any of these things occurs, the possibility of this thing could be that it belongs to one of these tags. So like that, we started teaching the algorithm how words are represented by application. So in naive Bayes, it's a very old theorem which is used. It's a probabilistic theorem which is used to classify based on the occurrences of keywords, and it's a simple probabilistic theory which all of us would be aware of. So of all the other algorithms which we tried, this one was giving very good results, and so we choose naive-Bayes. So after all this pre-processing and all this classification, etc., we were able to create a training data which looked like this. So this is like a portion of it. We created a training data which was almost 1 GB in size. So this one you would see, forgot password would belong to password reset, create new user would belong to register user, login here would belong to something else. So like that, we started manually tagging and creating different classified labels. But the problem with this particular thing is you cannot every day teach an application new things. So when it encounters something new, we wanted it to understand new and similar sentences as well. For that, what we did is we used something called as a cosine similarity. Since we already had the vectorized words, we simply checked the angle between these two vectors, and whatever was the closest, we kind of started adding it automatically to those labels. So that means when it encountered something which was not already in our training data set, for example, kindly use your account to log in. So this is a new sentence which was not already in the training data set. We used the cosine similarity to understand whether this was very similar. If it was similar, we added those, automatically started adding those to the training data set. So eventually, the more application it scans, it learns more about the language, it learns more about how to interact with those machines. So over here, what you can see, this is an example which I just mentioned. If a new sentence called, so forgot your username or password is already there in our training data. When it encounters something called as forgot user password, which is kind of similar, but it's altogether a different sentence, we used the cosine similarity to measure the similarity of these two sentences. If it actually fell in any of those label data, we automatically started adding it to the database. So this way, our training data kept improving over and over again, when we started scanning more applications. So the same way a human understands and gets better, the tool will also get better the more it scans the application, and it's also learning the different patterns and the different sentences which developers used to interact, to communicate. So with all these things, now the system we built was able to identify each labels on the web application. So when it encounters something called a sign up, it understands that a register user functionality is being performed here. So whatever payloads, whatever attack methodologies you have to do has to be automatically, whatever belongs to the register user has to be tried over here. So that means we were creating more context about the web application. We started, like a human does, right? We were able to understand what each label and each functionality does. And you are able to, so for example, you wanted to test for a password reset vulnerability, like a host header attack, etc., you would be actually able to, the automated solution would be actually able to easily understand that this is the exact place where you have to try those sort of attacks. So, by the way, the use cases of this particular thing is really high. There are so many different places you would be able to implement the use cases. One of them is, if you wanted to, like web application auditing is one where you can actually make the application, use the application without manual intervention. The tool would automatically interact every functionality of the application. Same way you could do mobile phone, mobile application automation as well, because again, all these applications are built for a human to interact with. So when you teach machines to understand those languages, you would be able to easily make them understand the languages. I mean, understand and use them much better. So a huge amount of the time which researchers or pen testers spend using the application could be actually solved using this. Also, the automated solutions as of right now, they are good in sending payloads, but the incapability of extracting new endpoints could be solved when you are actually teaching them how to use the language. So this way, with all the labelings, etc., we were able to reach to this stage where the application was able to understand different labels and was able to understand what that particular functionality was. Also, I have a question. How many web application pen testers are here? Web app pen testers. So I have a question for you. So when you test a new application, right? What functionality do you normally test? Do you really go straight away to the forgot password functionality, or do you test the different features in the edit my profile or things in my profile? What would you test?
First of all, to last test,
the Yeah. So.
Do you hear me well?
Yeah, I can hear. So you mentioned about the password reset.
Regarding password reset, yes, question. Yes,
So
of course.
no, when you encounter a new web application, what do you test first? And which functionality do you go first?
Oh, of course, user input.
Yeah,
fields.
you log in and.
Login, yes. Then all user inputs.
Yeah, so
must be checked first of all, of course, and then network traffics, HTTP headers, and so on. Is SSL encryption used, and so on, OWASP pattern.
So the thing I was trying to get the functionality right. Once you log in, most of the testers directly go to my profile, edit my profile, or
yes.
my settings page.
Yes.
Right. Most of the people go to my settings page. This is we spend a lot of time researching the activities of a normal pen tester, when we identified that every pen tester, after logging into a web application, he goes to my settings page where you would be able to manage the settings of the user. I think, can you agree with me on that?
Yes.
Yeah, so that is basically, thanks a lot. That basically comes from your previous learning, where what we understood is the most number of times you see a feature, you have the tendency to go to that particular feature. So that means if you start seeing my settings like 10 different times around 10 different testing, you obviously have the tendency to go to my settings and do the testing, because you might have either found a bug over there, and that's something you have been repeatedly seeing. So we wanted to create the same mechanism in our algorithm as well, where the navigation, how a web application is navigated, has to be the same way a human does the navigation. So for that reason, what we did is this particular input, that what does a normal pen tester encounter, or what does a normal pen tester reach every time he tests a web application. So we understood that edit profile, once he logs in, he goes to the profile user, or if he's not logged in, he goes to the create user. So the different patterns, we actually we actually implemented them using a decision tree, so that if the user is not logged in, he should be actually able to go to, if it's logged in, he should be able to go to the profile user and test functionalities over there. If he's not logged in, he should go to registration of user, etc. And then we started giving each of these labels a weight, which states that the more applications you scan, the more number of labels you encounter, give them an additional weight. So that means if the application saw 10 different my settings page, then the first feature it would test is the my settings page. So like that, we started giving them a different weightage based on the common pattern we saw with researchers, and we created an algorithm where based on decision tree, that each of this weight would be used to calculate the next movement it should make. Also, we did one more thing, that if an application has to proceed forward, right? So these are the labels which we identified, that next, yes, continue, search, repeat, follow, order, save. If you want to perform an action forward, if you want to perform, if you want to go to the next step or the next web page in an application, these are the common labels which were encountered, and these were the labels which were used to go forward. So we created a category called forward labels, and then we created called a backward labels. That's back, no, abroad, etc. Things like that. So whenever any of these things is encountered, if the application is supposed to move forward, it would choose one of these options. If the application is supposed to stop or abroad over there, it would actually choose this option. So this way, we were able to actually make the application move forward and interact with the application it's testing in a more human-like way. So I'll show you the demo. So basically now the system was able to identify labels. It can also identify the steps it should take to reach a particular destination. Also, can anyone suggest a web application, any common web application in Russia, but in English actually? We can do a small demo. Any web page names? Index? Microsoft? Com. Okay. One was Yandex and Microsoft Go. You have any more suggestions? All right. What we'll basically do is.
PHDays, да? Нам нужен динамический сайт. Что-то PHDays, да? Positive Technologies. Это же в России. Ага, он на русском. Переведено все.
So yeah, it's actually in Russian. So as of now, the tool is only able to identify Russian, but then with a little bit of conversion, you would be able to do the same the same technology could be applied to other languages as well. So I would just stick with Yandex or Microsoft. Any applications which belongs to Yandex or Microsoft? Any very specific dynamic application would be very much better. Yandex. Mail. Okay. I'll go for the mail. So I think 1 minute. Let me just check. Yeah, it's English. It's English. Okay, it's good. So we'll just stick with the Yandex actually. So basically it will start a browser and so you can see the debug over here. So it went to Yandex. Now it identified that there is a registration user and login user pages. So it will navigate to the live demos are always bad. Yeah, so basically it went to mail.yandex. Now it should identify, it should all by default understand that there is no registered user, so it should go to register user. Yeah, it went to register user. Now it identified that the application. What is happening?
Try another site.
Yeah, but the error is. it's creating some sort of error. I'm not quite sure. Yeah, just try one more time. Because the error is something different. I think the net is a problem. Yeah, it's working now. I think it was, I'm not quite sure what the problem was. Oh, now it's encountered SMS. Yeah, I mean, yeah. So it encountered this is like a captcha sort of thing where they're verifying using SMS. So you can see the debug log that it actually, it was asking for the first name, then it understood that it was asking for the name, surname, it was asking for the username, it entered a username. When it actually encountered something confirmation code from SMS, it sent a label OTP, so it aborted because you need to actually have the OTP, so which is similar to a captcha. So we will not be able to handle captcha sort of systems, but without, the point is, it was able to understand all the labels which was mentioned in the application and able to reach till this stage. But other applications, we would be able to do much better job, and most of the cases the live demo is really bad. So yeah, yeah. So as of now, it can't solve captcha or OTP systems, but all the other user interactions, it would be able to understand what the application is saying, and would be able to provide the relevant input based on the. So it asks for the username, it entered the username, it asks for the password, it entered the password, etc., without knowing anything about the application. So the same concept, it could be used for other applications as well, and would be able to test. So like I said, the use cases are different a lot. We've been testing it with a huge number of applications. It was able to find many issues because it was able to traverse to different parts of an application. For example, a file upload, where the file upload option was asking the user to enter any of these file formats, and since the application was able to understand that this is the expected file formats, it was trying different other file formats, etc., and we were able to find code execution bugs in many big popular portals. The same concept when you have context of the application, right? It knows that this particular request is for a forgot password, or this particular request is to delete a particular user. When you have the context, you would be able to create much more test cases. In one of the cases, we were able to, Pizza Hut is like a pizza delivery app. We are able to find delivery application. We are able to find issues which can order free pizzas. The idea was it was able to navigate and use those functionality from the previous learning and from the labels which was mentioned over there. And this technology is very good for extracting API endpoints. So like I said, almost all the new generation web applications are built heavily on JavaScript. So it's very important that the JavaScript endpoints are triggered, or the user interaction is correctly done in order for the right endpoint to be triggered. So the same concept could be used for mobile app automation as well. As of now, we use it for it's like free technology which we use it for automating web applications. So I think yeah, I'm kind of I'll take the 10 minutes for questions if you have any.
You use Python or
Yeah, so the thing is built on top of Python, and we use commonly used machine learning, Python machine learning libraries as well.
Is this application for defenders or for hackers? So I'm explain why I'm asking because
both actually.
okay, because as the defender I know my application, I know login page. So if I am hacker, I'm can use this for scan network and to find vulnerabilities in applications which I don't know. So this first question, for whom this is done. And the second question is, how can I contrast to this application, and which probability of success of the for finding vulnerabilities in my application, which I'm scanning.
So the payloads, everything is very traditional. All the payloads which are used by other web application scanners is used in the background. The difference which we are doing is the way we are actually interacting with the application. So for that, it should answer your question as well, that this is made for a tester as well as an application, a normal application guy. So he could actually make a machine interact with the different features of his application which we built. So it's built for both, but yeah, primarily we use it for security testing or hack attacks on other applications to find the security issues. And how good it is, well, like I said, as of now, all the crawlers which are being used by other applications, automated security solutions, they don't have any intelligence in it. They don't understand where to go for or what to choose. They blindly follow a particular set of instructions and try to reach their destination. But then when you build more intelligent solutions which can get better and better over each scanning, so that's what we are trying to do over here. So you scan 10 different applications, your scanner would now be much more intelligent than where it was like on the first day. So that's what we are trying to do.
Thank you.
First question is, which is precision recall rate for labels recognition about?
Which is, I'm sorry?
Precision recall rate.
Oh, okay. So we've been training the data sets for almost a year, less than a year, actually 8 to 9 months, and we were able to reach 92% with most of the labels. But sometimes what we have seen is when it encounters a new, very, very new label which says, sometimes some developers have a funny name of labeling something or a functionality. So those things, when it encounters, it totally doesn't understand. So there we need to have manual assistance to teach to train. So like I said, this is a supervised learning. We are trying to make it more unsupervised, but then as of now, it's a supervised learning. We are training it with when it encounters something it doesn't know.
Okay, and second question, are you trying to follow only one top scenario for page, or you're trying to follow multiple most probable scenario for page?
So as of now we are trying to do multiple probable scenarios. Like I said, this weighting algorithm, this particular weightage helps in taking that decision. So whatever is the highest probability, we try to choose that. If he doesn't know that particular thing, we kind of move it to an unlabeled category where next a human was actually going to teach it what it should be. So as of now, to very specific answer would be multiple probable.
Do those labels assign some kind of automatical algorithm or just enter them by hands?
So initially when we started, we created those labels, very few labels we created.
So you first create them?
Yeah, so like I said, in this...
So if some unknown site is met, there's no possibility to...
No. So like I said, we created, like, let's say, the training data, right? We created few training data, and then we use an algorithm to find similar So initially we created some, but the 1 GB of data, like I said, which we collected was automatically created using the cosine similarity algorithm. We found which is something which is similar to forgot password. We started automatically adding that label to the classifier.
Yeah,
So,
thank you.
Yeah. So if you have any questions, I would be around actually for some time. Just let me know. That's it. That's it from my side. Thank you.